Hello everybody, let's continue with example 7. So question says find the value of the angle theta in degrees in each of the following triangles, giving your answer correct to 1 decimal place. Okay, angles are always by default to 1 decimal place. If the question says to 2 decimal places or 3 decimal places, then you follow. Okay, but anyway, in this question it's 1 decimal place. Now we look at this triangle, theta is over here. So recall that the side that is opposite the angle is known as the opposite. And of course, if the side is opposite the right angle, it will be known as the hypotenuse. So BC is the hypotenuse and AC is opposite. So if we have the opposite and the hypotenuse, and we have an angle here, of course, remember, you will use so, okay, which is sine. Sine is opposite over hypotenuse. So write down your equation. Sine theta is equals to opposite over hypotenuse. How do I find theta? I will take sine inverse of this ratio 9/11. Press my calculator. So sine inverse of 9/11 gives me 54.9 degree to 1 decimal place. 54.9 degree to 1 decimal place. And that's your answer. Okay, moving on to part B. Alright, this is another right angle triangle. So let's look at where our sides are. Now the angle that we care about is over here. That is our angle theta. So opposite that angle is this side AB, which is 5. And adjacent to this angle is this side BC, which is 12. Oh my god, this is too pink. Change color. Let me change it to blue. Okay. So if we have our opposite and our adjacent side, we're going to use TOA because tangent of an angle is opposite over adjacent, right? Remember your tuakaso? So let's form the equation. Tangent theta is equals to opposite over adjacent, right? Which is 5/12. And how do we find theta? We take tangent inverse 5/12. Press calculator. And our answer is 22.6, okay, to 1 decimal place. So 22.6 degrees, 1 decimal place. Easy. All right. Part C. Okay, this is another right angle triangle. Our angle theta is over here, happily sitting in one corner. And then we look at side AB, which is over here. This side is adjacent to the angle, right? And how about this side? This side is obviously the hypotenuse because it's opposite the right angle. So if we have the adjacent and the hypotenuse, of course we have to use cosine because remember CAH, car. Cosine is adjacent over hypotenuse. So from the equation, cosine theta is equals to adjacent over hypotenuse. To find theta, we take cosine inverse 10/14.5. Press calculator. Cosine inverse 10 divided by 14.5. Answer is 46.4. 46.4 degrees to 1 decimal place. Okay, please do your rounding up and rounding down accordingly. The calculator tells me it's 46.397. So of course we round up to 46.4. Give your answer to 1 dp. Okay, part D. Let's go. We are supposed to find theta, but theta is in this weird triangle over here. Okay, triangle ABC is obviously not a right angled triangle, but triangle ABD is a right angled triangle. So you have to be very careful. Every time you apply tuakaso, you must make sure that it's for a right angled triangle. Okay, if not, it doesn't make sense, right? Because there is no hypotenuse. Then how can you say this side is opposite, this side is adjacent and all that? So you must ensure that it's a right angled triangle. Now, let's look at the diagram first. In this diagram, you can actually see that there are two right angled triangles. Okay, one is triangle ACD, the smaller one over here, and one is triangle ABD, which is the bigger one over here. Both are right angled triangles. So let's look at triangle ACD first. we can actually find the angle over here because we have 7.2 and 9.6 given, right, for triangle ACD. So we actually have the adjacent side 7.2 and the hypotenuse 9.6. So I'm going to write down in triangle ACD, okay, if I take cosine of angle CAD, because I got adjacent and hypotenuse, right? So I have to use cosine. Okay, cosine of angle CAD will actually be equals to 7.2 over 9.6, adjacent over hypotenuse. Okay, so how do I find angle CAD? I'll take cosine inverse of 7.2 over 9.6. Press calculator. Cosine inverse 7.2 divided by 9.6. I will get 41.4. Now this is not my final answer, right? My final answer is to find theta. So I should not give this to 1 dp. I should give it to more than 1 dp. So maybe I'll give it to 3 dp. Okay, 41.4096K. The more the merrier. So 4 dp. Okay, this one is to 4 dp. Now, if we look at the other bigger right angle triangle, which is triangle ABD, we can find the whole of angle BAD, which is this one over here. Because once again, we have the adjacent and the hypotenuse of the bigger triangle. Can you see that the adjacent of the bigger triangle, it is still 7.2 because we're looking at angle BAD, and the hypotenuse is now 15. Okay, so let me do my working here. For triangle BAD, or I shall call it ABD, okay, once again, if I use cosine angle BAD, adjacent side is 7.2, hypotenuse of the bigger triangle is 15. Okay, so I find my angle BAD by taking cosine inverse of 7.2 over 15 now. Okay, choose the correct hypotenuse for the correct triangle. And then you press calculator, cosine inverse 7.2 divided by 15, you will get 61.31459 and so on. Once again, let me give it to more than 1 dp because this is still my working step. So 61.31455. Okay, I truncate for dp. Okay, so to find theta, right, my final step is to find theta. I will just take angle BAD, which is the big angle over here, and minus away angle CAD, which is what we found initially. Okay, and then I'll get my theta immediately. So theta is equals to 61.3145 minus away 41.4096. Press calculator, 41.4096. I will get 19.9. Aha, this is my theta to 1 decimal place. Very good. So even though the diagram looks a little bit complicated, you just have to identify the two right angle triangles, identify which are the adjacent sides, which are the respective hypotenuses, then find your angles and then find theta. Okay, it is pretty simple once you get the hang of it. Okay, let's move on to example 8. In the diagram, angle RPQ equals to 34 degrees, which is over here, 34 degrees. Okay, angle RQP is equals to 90 degree, which is over here. RQ is equals to 12, which is here. And PS is equals to 10 cm. So only this part is 10. Okay. Question says find the length of QS, which is this length over here. Okay. Now in this question, they have given you the angle already, and you're supposed to find a missing length. So this is what you learned in your previous section. Let's change to blue color. Now, I have the angle here 34 degree. I have the opposite side, which is 12, and I need some information about the adjacent side, which is PQ. So I'm going to use tangent because I have opposite and I want to find adjacent. Okay, so I'm going to use tangent 34 degree equals to opposite over adjacent, which is my 10 plus SQ. Okay, but for now I just write it as PQ because that is the whole of the adjacent side. So to find PQ, I will cross multiply. PQ tangent 34 equals to 12. Therefore, PQ is equals to 12 divided by tangent 34. Press calculator. So 12 divided by tangent 34. I will get 17.7907. Okay, so this is not my final answer yet. So once again, I will write it to more than 3 SF. 17.790. Maybe I write it to 5 SF. Okay. And then I want to find QS, right? So I just have to take 17.790 and subtract away 10. Okay, must write units, right? cm. Okay, so minus 10, I will get 7.79. 7.79 cm. Lengths must be given to 3 SF for final answer. Okay, so remember angles are to 1 decimal place and then the lengths are to 3 SF. So answer is 7.79 for QS. Alright, part B says find the angle beta, which is over here. Let's use green color because my blood is green. Alright, now how do I find angle beta? I realized that beta is inside this triangle PRS, but that PRS is not a right angle triangle. So we have to do something similar to what we did previously, okay, which is to find this bigger angle first. Okay, we have to find this big angle, which is PRQ. Then we have to find the small angle SRQ, and then subtract them to find your beta. Okay, so let's do it step by step. For part B, let's find the small angle first, which is SRQ. Okay, now I already know QS from the previous part, right? And I already know the adjacent side, which is 12. So I'm going to write down tangent of angle SRQ is equals to opposite over adjacent. Opposite is SQ, but because this is a working step, I'm going to use my 5SF value. Actually, the 5SF value is very similar to the 3SF value. In this case, okay, 7.7907. 1, 2, 3, 4, 5. Okay, and then take it over the adjacent side, which is 12. So if I go and press calculator to find angle SRQ, I will get tangent inverse 7.7907 over 12. Answer is tangent inverse also divided by 12. I'll get 32.9927. I'm just going to give it to 4 decimal place, which is like more than 1 decimal place for angle. Okay, then similarly, I'm going to find my angle PRQ, which is the big angle over here. Okay, so for that, right, I'm also going to use tangent because I have PQ and I have the adjacent side, which is 12. So tangent angle PRQ is equals to opposite, which is PQ, 17.790 over adjacent, which is 12. Okay, then I go and find my PRQ, which is tangent inverse 17.790 over 12. Press calculator. 17.790 divided by 12. You get 55.9989 to 4 decimal places. Okay, with that I can easily find beta because I just take 55.9989 minus away 32.9927. My final answer will be 23.0 degrees to 1 decimal place. And we're done.